Okay. There's something I need to make everyone aware of, in case it might affect anyone. Last night, I was looking at SOAR, my faculty center that shows all my classes, and my 2 sections of 102, so your classes, were gone from that list. So then I looked in Canvas, and I saw that my 102 sections were also not on my course list there. So basically, my 102 classes had been taken away from me. I sent several frantic emails about the matter, and what I discovered was that it was a mistake, naturally, one would hope. And someone who was inputting schedule information for spring accidentally did that for fall, and caused these 102 classes to be reassigned to somebody else. Therefore, I could not do anything in Canvas. I could not even respond to messages from any of you in Canvas that I had received previously. It basically, from my point of view anyway, shut the whole course down. Now, at least we're all here now, so presumably the problem has been resolved. If anyone had sent me a message through Canvas during that time, so we're talking like roughly after 5 p.m. yesterday until this morning, then I would not have received it, and who knows where it would have went. So I could check to see if there's anything that came in the meantime once access was restored. But so hopefully it did not actually affect any of you. Whatever happened, this is an issue in SOAR. It did not affect Hawks whatsoever, as far as I can tell. So, so maybe it didn't affect any of you, but I'm just letting you know that this happened, and everything should be back to normal now. Okay, I need to share my screen real quick. Okay, so you should see the course homepage in Canvas in front of you. So one to make all of you aware of. So for example, if I go to the link here for our previous class meeting, the one that happened on Monday. So this is what it will look like. This is for every class meeting or office hour after it's taken place here in Teams. So I posted a link to the video from a recording in Microsoft Stream, although some students had trouble accessing it. So the same video is also available in YouTube, and that should certainly work for everybody. Whatever notes I typed up from working out problems during that class meeting, that will also be posted here. So, so as soon as possible after class is over, although it may take a bit, a few hours or so, everything from that class will show up here in the Canvas discussion item. So if you miss it, or you just need to look back at these materials, this is where you'll find them. Okay. Now, I've seen that in Hawks, the majority of you have at least gone into Hawks to start working, but it's only like 70-something students when there are roughly 100 in total. So hopefully everyone else gets into Hawks soon. A lot of people, or maybe not a lot, but several people have finished the first assignments and even gone ahead, so that's good. So the plan for today is to continue from where I left off on our last class meeting on Monday. I had gone through much of the Chapter 1 review, your first assignment in Hawks, which is due on Tuesday, August 25th. So today I will go through the rest of the problems. So we're going to be looking at things like factoring and also tasks to be performing frequently all semester, like finding the equation for a line, given information about that line. Whatever time we have left, we'll use for any homework questions. And let me check in the chat here. Okay. Also, as a reminder, tomorrow at from 9:30 to 10:30, I will be here in Teams. That will be 102 office hour. So any questions you have, I'll be there for that. Now, as I go through these, the only thing I'll be seeing in my window is these math problems that I'm working through. I'm not able to see the Teams window. I might get a noisy notification. So if you have a question, feel free to shout it out. I'll try to return to the Teams window now and then so I can see if anybody has a hand up or said something in the chat. And I think I get some notifications for those on my phone. Okay, so what we have here are some factoring problems, so the kind of problems that you would have carried out in Math 101, and certainly will be needed here from time to time. So in this problem, the goal is to find any common factors from these terms and factor those out. And so your answer is actually going to be the full factorization of this. So whatever common factor you've been able to extract times everything else that's left over. So what you'd be doing is looking at each term, seeing if there are any constant factors that could be factored out. That won't happen in this case. Like here we have a coefficient of 1. Here we have a coefficient of 13. There is no common factor, 13 being a prime number. So there won't be anything to factor out in terms of numbers. In terms of x and y, what you need to do is look at the powers of x and y. And whatever is the lowest power of x or y that you find in the whole expression, that is what you're able to factor out. So if you look at the two terms, here we have x squared, and then here we just have x, which is the same as x to the first power. So that gives us a common factor of x. Then if we look at y, we have a y to the first power here. We don't have a y here at all. So that's the same as y to the 0. So there is no power of y that we can factor out. So the greatest common factor is just x. So the factorization, you're going to have x, and then it's going to be everything in here divided by x. So I have x squared over x plus 13xy also divided by x. So this is a good way to write it in order to minimize mistakes. You can handle each term in here individually. So then you simplify this as much as you can. So we still have the x out front. So then x squared over x. That's the same as x squared over x to the first power. You subtract the exponent, so what's left is just x. And then here, the x's will cancel. So you're left with 13y. So that is the final answer in this case. So look at the powers. Lowest power wins as far as finding a common factor. Questions on that one? The next few problems, the next four actually are problems I imagine you had to do frequently in 101. We have quadratic functions to be factored, and there's different approaches that one can take. So for so this one, if I want to write this as sort of a form of factorization, since we just have a plain old z squared, there's no coefficient here. So we have z plus a times z plus b, where a and b are unknown. So if you were to multiply this out, it has to equal this. So that would mean that a plus b, because we multiply this out, you get z squared, so that's fine. You have az plus bz must equal 11z. So in other words, a plus b has to equal 11. And then we have a times b has to equal 28. So really what you're doing is you're looking at factors of 28. You want to find two, and it's generally the easiest way to proceed. Think of two numbers whose product is 28, but their sum would be 11. Since all the terms here are positive, so a times b must be 28, and a plus b is a positive number. So that tells you a and b will both be positive, whereas in some cases you'll have to have one or both of these be negative. So what would be two numbers that multiply out to 28, but their sum is 11? Anyone?
7 and 4.
Yeah, 7 and 4. So what we get is, so that's the answer in this case. So z plus 4 times z plus 7. And of course, it won't matter what order you enter the factors in, and Hawks would be smart enough to figure it out in either case, whether it's z plus 4, z plus 7, or z plus 7 times z plus 4. Okay, so in the next problem, we take the same approach. So x plus a times x plus b, where, so in this case, ax plus bx is going to be 4x. So a plus b must equal 4. And then a times b is equal to minus 45. So one of these, exactly one of these, a or b, is negative. So a good way to think of it is, so if you think of two numbers whose product is 45, and since one of them has to be negative, then you're really looking at a difference of these numbers being 4. So so what numbers would work in that case?
9 and negative 5.
9 and negative 5.
Yeah, 9 and negative 5. So what we get here is, this is your factorization, because we have minus 5x plus 9x is equal to 4x, so that works. And the product is minus 45. If it'd be the other way around, like suppose this was x squared minus 4x minus 45, then you would just change the signs here, and that would work. Okay. One more of this type. So here we have a plus b is equal to minus 16, but a times b is equal to plus 63. So what does that tell us about, because the previous two examples ago we had both positive. Here, one of them needed to be negative. What can we say about the sign of these, just positive versus negative in this case?
Both of them need to be
Both negative.
Both must be negative because their product is positive, but their sum has to be negative. So, so what are two numbers whose product is 63, we can just negate both of them and add up to 16.
9 and 7.
Negative 9 and 7.
Yes. So that would be the answer in this case. So y minus 7, y minus 9. Okay. Next one, a bit trickier because now we have a coefficient of z squared, the quadratic term, that is not 1. So we need a different form of the factorization. So I could write it this way. Okay. So what happens here is if you were to FOIL this out, as I mentioned last time, that's so a times c must equal this coefficient. Then from the outer terms, we have a times minus d, and then the inner terms, b times c. So bc minus ad has to equal minus 9. But we have 4 unknowns there. And then these numbers, b times minus d, must equal, oh, that should be minus. Oh, okay. I had the minus put in there already. So minus BD equals minus 20. Therefore, BD by itself must equal plus 20. So what you would want to do, what you could do, again, there's different approaches we can take to this problem that I'll show you. You could go through the different factors of 20. As possibilities for A and C, and also for B and D, and see which combination works. So depending on the numbers involved, you might get lucky and hit a combination pretty quickly that works. Or you might get unlucky and be going at it for quite a while. But there's other things we can do to tackle a problem like this that would certainly be overkill for the previous ones, but become more viable for this one, just to try to solve it a little more quickly. So could anyone suggest, and there's more than one right answer here, a different approach to factoring this than just trying numbers in here?
Maybe the P and Q method.
Sorry, what?
P's and Q's method. Or you
Okay.
do that? I don't know.
Okay. I might know what you're referring to by different name. Or also the audio is pretty bad, so I thought I heard like a P and Q method.
Yeah.
Okay. Again, I might know it by a different name. Okay. Because one thing you could do, and let me know if this is what you're referring to. But I'm gonna make sure this is on a new page so everything can be seen. Okay, so this is one thing you could do. Whoops. Is you can take the middle term, and you can rewrite it in any way. Here I've broken it up into 2 terms. So 16z minus 25z is minus 9z, but not just any numbers that add up to minus 9. What I've chosen here are numbers that have common factors with the other coefficients in here, which would be 20 and minus 20. So, for example, minus 9 can be written as 16 minus 25. So this is factoring by grouping, because then what you can do is look at the first 2 terms. What's the common factor? So 20 and 16 have a common factor of 4. And here we have z squared and z. So there's a common factor of z. So 4z gets factored out. So then what's left? If we factor out a 4z, again, only looking at these 2 terms right now, This is okay. Hold on, I'm answering a message from one of you in the chat. Okay. Yeah, Desiree, I couldn't hear you, but or there might have been some other noise that got in the way. Do you have a question? Please let me know, like in the chat. Okay. Yeah, I wonder because of your camera kept cutting in and out. Okay. I'll keep an eye on the chat. So then if I'm so this comes about from factoring the first two terms. Now if I move to the last two terms, what's a common factor here? There's no common factor involving z because we don't have a z in this term. Here, 25 and 20 share a common factor of 5. So I'll pull out a minus 5. And what's left? The same thing, 5z plus 4. So 5z plus 4 is a common factor in this group of terms and this group of terms. So then I could pull that out of all of this. And what's left? 4z minus 5. So that is one way. Admittedly, there's a little bit of, in both approaches we see here, there is some trial and error involved.
I have a question. Where did 16 and negative 25 come from?
I'm sorry, can you repeat?
Where did the 16 and negative 25 come from?
Okay, so here's what I did. I wanted to find two numbers that sum to minus 9. Now that's a lot of possibilities there, of course. But I also wanted to choose numbers that had common factors with the other coefficients in here, which are both, they're plus or minus 20. The reason for that is when I look at these terms, I want to be able to factor out something. So if I chose a different combination, like suppose I chose, instead of 16 and minus 25, suppose I chose, let's say 14z minus 23z. Well, that does add up to minus 9z, except if I have like a 14 here and a 23 here, 14 and 20, they do have a common factor. So I could have factored out something there, but like if I have say a minus 23z here, 23 and 20 do not have common factors. So that was guiding my choice of these two terms to subtract.
All right, I got it. Thank you.
Okay. Can anyone tell me an approach to getting this factorization that does not require any trial and error? It's kind of a pain, but there is. Yes, the quadratic formula. Let's take a look at that. So that's something you can always use for certain problems, like the previous ones. Again, it'd be overkill, but for this one, I actually find it a good idea. So here I have minus b. Well, b is minus 9, so I'll have 9 plus or minus square root of, this is minus 9 squared gives me 81 minus 4ac all over 2a. So then when this is worked out, what you get is, okay, I'll fill it in here. So 40 down below, and then 9 plus or minus square root of 1,681, which happens to be a perfect square, but you don't need to know that. Your calculator can tell you that. Okay, let me use a plus minus symbol here. Okay. So we have 9 plus or minus 41 over 40. And so when you work all that out and get everything in lowest terms, these are your two roots. So minus 4/5 and 5/4. So so that helps. But so now you want to go from those roots to factors. So if I have, okay, these roots are z. So if z is equal to the first root, so minus 4/5, so I have this equation down here. So I can rearrange this to get a factor. Z plus 4/5 is equal to 0. And then from the other root, okay, well, actually, I can go further. Now I can multiply both sides of this equation by 5, and I get 5z plus 4 is 0. And then I could do the same with the other root, 5/4. Z is equal to 5/4, so I can rearrange this. And then I have this denominator of 4. I want to get rid of that denominator, so I can multiply both sides by 4 and get 4z minus 5 is 0. So here I have two factors, and if I were to multiply them out, like 5z times 4z would give me 20z squared, which is what I want. So that's another way to get to factorization. That does not require any trial and error with the factors of your coefficients. So it's not too often where you might actually need to use the quadratic formula, but it's always a good backup. Okay, see something in the chat? Wait. Okay. Sorry, seeing your question in the chat, Desiree, that you multiplied the whole thing by 20.
Can y'all hear me with this mute off?
I can hear you.
Okay, so sorry. I switched my headphones. I think they're just broke. Okay. Basically, the only way that I know how to do it well, and it may just help somebody else just because, I don't know, I have that algebra mindset. I basically just take that first 20 and I multiply it to the very end number, which is also 20. And then I factor it like normal. So it turns into basically z squared minus 9z minus 400. It makes a big number at the end. And then I just factor it like normal, so I don't have to worry about that coefficient. And then when you do that, you should get z plus 16 times z minus 25.
That's right.
Yes, sir.
I need you to back up, please.
Okay.
Sorry, you're going too fast.
Okay.
Okay. I have the original problem rewritten here.
Yes, sir.
Please explain one step at a time.
Okay. I'm sorry. I didn't know that you were writing it down.
Yeah, I want everyone to see.
Yes, sir. Okay, so I multiply the 20 coefficient from the very beginning all the way to the very last number.
Right, so yeah, it's 400.
And so, okay, then it would be z squared minus 9z minus 400.
Okay. That.
Yes, sir. Okay, I promise you I'm not crazy. This is how I do it.
Okay,
And then
your way it's looking is that you're changing a problem to something completely different.
no, I promise you I'm gonna I'll change it back. I promise you. Okay, so, and then my next step is I factor that like normal. It has a huge number at the end, and it takes a couple trials, but it just makes it easier for me to visualize it because there's no coefficient. And so when you do that, you get z plus 16 and then z minus 25. Okay, and then right there, you have to remember that coefficient that you multiplied, and it's almost like you do the opposite step. And so I divide the 16 by 20 and the 25 by 20.
Okay.
The only reason that I do this is because my previous like teacher I had in high school, I struggled so much with trying to figure out the test method, and so we went around and around, and we finally found this method, and it helps me. So I'm not sure if it might help somebody else.
Okay. Here's my concern: is that I would need to have a feel for what kind of situations this would work for, but maybe situations for which it would not work. So, in other words, because since what you're doing here is you're making a significant change to what it is that you're supposed to be factoring, and just by taking, so if I'm understanding you correctly, right? But you're taking this coefficient and moving it over here.
Yes, sir. I multiply it, and then I just divide that original coefficient to the answer, the 16 and the 25, and then it gives you negative 4 over 5 and then 5 over 4.
Here's what I'll do. I don't want to take too much time on this, but I think we're doing pretty good on time. So, okay. So if I were to look a little more abstractly about what you did, just think, because here you have az squared plus bz plus c for whatever choices of a, b, and c. And you are changing it to this, correct?
Yes, sir.
Okay. Now, let's take a look at what the quadratic formula would give us for this one compared to this one. So we have.
Well, if you plugged those numbers into the quadratic formula, it would be different, but it's the step to where you divide it that gets you it should be the correct answer.
And I'm trying to prove that. So, yes, I do understand it'd be different, but I want what you're doing. I want to see it shown rigorously, because what happens here is, sure enough. Okay, wait, this isn't rendering yet. Okay. Another brace here. Okay, so here I'm able to validate why this works. Because I'll show both expressions. So the original quadratic formula would give you this. Applying quadratic formula to the revised expression gives you exactly the numerator, but just 2 down below instead of. So what I'm doing is I'm showing everyone why that works, or why the technique you described works. As long as you divide by a at the end.
Yes, sir.
Okay. So I just have not heard of this approach. So when you described it to me, it seemed strange.
Yes, sir.
So as a mathematician, I need to do this.
Okay, that's understandable.
Yeah, so that not only can I be convinced that this is kosher for all problems, because There are cases where teacher teaches some trick to her students, doesn't really explain why the trick works, but you see that it works.
Mm-hmm.
And the student may not be aware that it doesn't work in every situation.
Yes, sir. No, I know. I just,
Yeah.
that's the only way that I was able to understand it. So I was trying to get my mic to work earlier. I was like, well, maybe this will help somebody because,
Yeah.
I don't know. There's two different approaches, I guess. But thank you so much for explaining it like that. That actually helps me a little bit too.
Okay. Well, I appreciate you sharing it because, no. Okay. Yeah, because then you're just focusing on one of the factors of 400. Okay.
Yes, sir.
Okay. Any questions that anyone has about these factoring problems before we move to a different type of problem? Okay. Now, one thing that you'll have to be doing frequently in this class is finding equations of lines for various reasons. So it's important that we deal with this. So, for example, problems such as this, here are 2 points in the plane. So x is 6, y is 5 for 1 point, x is 0, y is 7 for the other. So to find the equation of a line passing through these 2 points, you need to find the slope. Now, for some of you, this may seem like an overly simple thing, but I can tell you from several years of teaching this class, there are several homework problems that you will see where you'll be given a graph that shows a line, and you'll be given points on the line, so it'll actually show you what the points are. Like you don't even need to read it off a graph. And then the question asks, what is the slope of this line? And a bunch of you will get it wrong, and I will have even more gray hair. So this has got to stop because it's something that drives me crazy every semester that I teach this class. So take your y values, subtract them up top. Take your x values, subtract those down below. Make sure that you have the x and y values in the correct order. So here I have the second y value minus the first, so 7 minus 5. And second x value minus the first, 0 minus 6. And then you work all that out, simplify as much as you can. So in this case, we get 2 over minus 6. So simplify that and you get minus 1/3. I have Hawks give credit if an answer is correct, but not necessarily simplified. So you would not lose points for something like this. And when I see wrong answers, I wonder, is there a pattern to them? Like some people might have the x and y backwards, so they end up getting an answer that's 1 over this, but some answers seem to have no explanation like that at all. So these are among the easiest points you can get all semester long. Don't give them away. So difference in y's over difference in x's. Look at your ordered pairs closely. Identify which are the y values, 7 and 5 in this case, which are the x values, 0 and 6 in this case. And as a step beyond that problem, so here we have this information given where you might have to compute the slope, and once you have the slope, so in this case it's given to you, and then you're given 1 point on the line. So then the question is, what is the equation of a line? And here a question says, write the equation in slope-intercept form. That's one way of writing the equation of a line. What's the other commonly used form to write the equation of a line? What do we call that?
Point slope.
Point slope form. And certainly, given information, point slope form is the easier one to come up with. So you can write down the point slope form first. So we have y minus the given y value is equal to the slope times, and use your parentheses, x minus the given x value. So then here we have the equation of a line, but it's not in the right form. So slope intercept form. Actually, I'll write out the equation. So y minus given y value is equal to slope times x minus the given x value. Okay. A slope intercept form is y is equal to mx plus b. So it turns out that if you have a point slope form already, if you were to multiply this out, b would be equal to the given y value minus the slope times the given x value. But what you can do is just take this and just multiply everything out. So distribute this minus 2/5 through this x minus 2. And this is what you get. So minus 2/5 x, and then you have minus 2/5 times minus 2. So that's plus 4/5. Okay. And one thing I want to show, because this is also a source of many mistakes, that, all right, so you multiply this out, you get minus 2/5 x plus 4/5. But then you take the minus 3 and move it to the other side. So we have that to deal with. So, and there'll be many cases where you have something like this and you want to get this over a common denominator. And in fact, there'll be certain situations that we'll get to when you're computing derivatives where you'll have a number to a fraction to subtract 1 from, things like this. And so there's a need for a common denominator, and I'll watch semi-helplessly as I see several of you mess it up. And I'm going to try to reduce that happening at least. So be very careful about how you combine such numbers. And I'll carry that out here. So here we have 3, but we have a denominator of 5. So you're going to rewrite the 3 as 15 over 5. And then you can combine the numerators, you can add the numerators, and that's how you get the final answer of 19 over 5. So very common task. Some of you may feel that it's a very rudimentary task, but I've seen enough people in this class make mistakes in that I wanted to harp on it a bit. Okay. Any questions about problems that I've presented here? Or about problems in Hawks? Anyone having difficulty with homework problems so far? Hopefully, at least all of you will have started soon. I'd like to say at the beginning of the semester, no one's behind yet. Certainly in this class, no one is behind yet. But I've found that some students have a knack for falling behind very efficiently. So, so no one has any homework questions. So tomorrow, 9:30 will also be an opportunity for any of you to ask questions there.
Could you go over another one of the factors where you have to find a variable?
Okay. So this one, you mean? Or
Another one like x squared plus 13x1.
okay. All right. So you want me to do another one of these?
Yes.
Okay. Okay. So I'll make something up. Let's see. Okay. So we'll try this one. So what do we have here? We have powers of x, we have powers of y, and we also have constant factors. So those are three things to look at: constant factors, powers of x, powers of y. So we go through this in order. First, look constant factors. All right. So if you look at the constant factors that we have here, 16 and 6. So what is the largest possible common factor of 16 and 6? Anyone?
Two.
Yeah. So both are divisible by 2. 16 is 4 times 4, but 6 is not divisible by 4. So it's only factors of 2 and 3. So here, so 2 will be a common factor that we can pull out. But then we look at our powers of x. So we look at the smallest power of x. So that would be the greatest common factor as far as x is concerned. So, so what we have here is we have x squared and x cubed. So x squared is the part of our greatest common factor. So far we have 2 and we have x squared that we can pull out of both of these terms. Then smallest power of y, which is
Y.
plain old y, or y to the first, because we have y cubed and then just a y by itself. So if we put all of that together, multiply all of these, so we have 2 x squared y. So that is what can be factored out. Okay, so what does that give us? All right, so that would be equal to our factor. And then we need to figure out what's left. So what I've written here is the original expression. So really all I'm doing is I'm multiplying and dividing by the common factor. And you can try to figure this out in your head, but in case you don't feel like you want to do that, you can always do this. Figure out your common factor, as I've done here, multiply and divide by it. Then all that's left is to simplify what's in here as much as you can. And because you've pulled out a common factor, there will definitely be simplification that you can make. So now, to carry that out, okay, so I'll just copy this down below. I see so many sins committed involving fractions. So we'll try to reduce those. So here, I can break this up into a sum of two fractions. All right, so okay, so all I've done is broke this up into two fractions by breaking up the terms in the numerator. You can do that by breaking up the terms in the numerator, not the denominator. Like if I had this fraction flipped over, could not do anything like this. Don't do that. Only in the numerator. Okay. Now, in each of these fractions, you remove any common factors. Okay. So here, like here, 16 over 2, that simplifies to 8. The x squareds cancel. Okay. And then y cubed over y, that simplifies to y squared. So in the end, you actually don't have a fraction at all anymore. Okay. What about the other one? We want to reduce this to lowest terms. So what will we end up with after you cancel whatever you can? So this fraction right here, what could it be reduced to?
3.
Okay, I heard a 3.
3x.
Okay. Yeah, the y's cancel, and then x, what's left is x cubed over x squared, and that simplifies to just plain old x. And that's it. That is the factorization by factoring out whatever you can. Okay. All right, questions on that one? Okay, I'm going to answer a question that I just saw in the chat. I'll make up a problem to go with it. So something like this. So here we have a relatively simple quadratic equation, and we see that in order to get the value of x, we need to take the square root. This is one of those situations where you need to remember take the positive and negative square roots. There will be several problems that we'll see during the semester where you need to find out where a given function is equal to 0. In some cases, that'll be like a higher degree polynomial, like a quadratic or a cubic. And you need to make sure to get all of the solutions. And that includes accounting for both positive and negative square roots. So be sure to not leave that out in that case. So the quadratic equation can have at most 2 solutions that might coincide, but again, at most 2. And if it's a cubic equation, at most 3, and so on. Okay, we still have some time. Other questions?
Can you scroll back down to the slope one?
The slope one?
Yeah.
Okay, this one or the other one?
Slope intercept.
Okay. Here we are.
I just need to finish right.
Okay. In the meantime, other questions? Okay, what I will do is I will stop the recording at this point. If anyone wants to ask questions, but not the whole class here, they're welcome to stick around. Everyone else is welcome to leave. Recording is stopping.